Hello friends and welcome to your channel GATE Questions ECE. So the next question that appeared this year in GATE exam is question number 61, and this question belongs to communication system, and this was a question of 2 marks. So the question is, the transition diagram of discrete mammalist channel with 3 input symbols and 3 output symbols is shown in the figure. So here it's given the transition diagram of discrete mammalist channel. The transition probabilities are as marked. So the transition probabilities are marked here. The parameter alpha lies in the range 0.25 to 1. The value alpha for which the capacity of this channel is maximized is dash. So we will have to find out the value of alpha for which capacity of this channel is maximized. So let's see how to solve this question. Firstly, I will write what is given in this question. So firstly, it's given the transition probability matrix that we can write from the transition diagram. So we will have 3 inputs A, B, C, and corresponding we can have 3 outputs A, B, and C. You can see from the diagram the first transition probability when input is A and output is A is 1 minus alpha, and when input is A and output is B is this probability is alpha, and this is 0. Similarly, we can write the transition probabilities of this row from the transition diagram. So we can see from B to B it's 1 minus alpha, and from B to C it's alpha. So from B to B it's 1 minus alpha, and from B to C it's alpha, and otherwise it's 0. Similarly, for the third row we can write from C to C it is 1 minus alpha, and from C to A it's alpha. So from C to C we can write it's 1 minus alpha, and C to A it's alpha, and otherwise it's 0. So this is the transition probability matrix that is given in the form of transition diagram of discrete mammalist channel. Next thing, it is given that alpha belongs to value 0.25 to 1. Alpha belongs to this range of values, and what we have to find out is value of alpha. We have to find out when capacity of the channel that we represent by CS is maximized or maximum. So now let's calculate this value of alpha for which this capacity is maximum. We know that the capacity of any channel is maximum value of its mutual information among input and output. Here input is X and output is Y. So these three are the possible values of input random variable X, and these three are the possible values of output random variable Y. And we have to maximize this mutual information for all the possible probability distributions of input. For all the probability distributions of input. And since this mutual information is equal to entropy of Y minus entropy of Y given X, so we can write it as maximum value for all probability distributions of input of entropy of Y output minus entropy of Y given input X. So let's first calculate this entropy. So we know the formula for the entropy Y given X is summation over probability that X is equal to Xi and joint probability Y is equal to Yj log 2 1 by transition probability that Y is equal to Yj given X is equal to Xi. where this summation is over all values of I and all values of j. We can express this joint probability in terms of this transition probability. Since this joint probability x is equal to xi and y is equal to yj is equal to probability that y is equal to yj given x is equal to xi times probability that x is equal to xi. So writing this formula in place of this formula, this we can write summation over all values of I, summation over all values of j, probability that y is equal to yj given x is equal to xi times probability that x is equal to xi log 2 1 by this same thing we can write here. Now you can note here that this probability x is equal to small xi is independent of j. So we can take this term out of this summation and write the entropy of y given x. I will write on next page. So we can write entropy y given x will be equal to summation over all values of I, probability x is equal to xi, summation bracket all values of j, probability y is equal to yj given x is equal to xi log 2 1 by probability y is equal to yj given x is equal to xi. So you can observe here that this expression in the bracket is nothing but the entropy of y given x is equal to small xi. This is the transition entropy for the input x is equal to small xi. So we can write this will be equal to summation over all xi or I, probability x is equal to small xi times entropy y given x is equal to xi. So in our given problem, let's calculate this entropy for each input. So in our given problem, let's calculate this first. X is equal to first input is A. So it will be equal to, you can observe from the transition matrix that we obtained earlier, it will be equal to 1 minus alpha log 2 1 over 1 minus alpha plus alpha log 2 1 over alpha. And we know we represent this function by an entropy function h of alpha. Similarly, you can calculate the entropy for other input x is equal to b and entropy for y given x is equal to c. Since the elements of all the rows are same as the elements of the first row, so we will get same result for each case. So this will be equal to h of alpha and this will be also equal to h of alpha. So now putting these values of entropy in this expression, we can calculate h of y given x for our given problem. So it will be equal to summation over all values of input xi, probability x is equal to xi times h of alpha. Now you note down carefully that h of alpha is independent of input probabilities. Since it is independent of input probabilities, we can take out this term out of this summation. So we can write it as h of alpha times summation over all values of input probability x is equal to xi. And we know this term, sum of all the probabilities of input is equal to 1. So this transition entropy is nothing but is equal to H of alpha. So now let's see what is the expression of capacity after we have obtained this transition entropy. So the capacity of this channel is maximum entropy of Y minus entropy Y given X, where this maximization is done over all the possible PDFs or PMF of input X. We have obtained this entropy Y given X and we observed that it is equal to H of alpha. So the capacity of the given channel in the problem will be maximum over all the possible probabilities of X, entropy of Y minus H of alpha. And we observe this H of alpha is independent of input probabilities. So we can say that with respect to all the possible input probabilities, H of alpha is constant, and since it is a constant, all we have to do is maximize this entropy to calculate the capacity of this channel. So we can write capacity of this channel is maximization of entropy of Y minus H of alpha. And we know that any marginal entropy is maximum only if that random variable is uniformly distributed. And if Y is uniformly distributed, then we can write that probability that Y is equal to Yj is equal to 1 by the size of Y, number of possible values of random variable Y. In our case, the output random variable Y can have values A, B or C. So the size of random variable Y is 3. So the probability capital Y is equal to small y will be equal to 1 by 3. And correspondingly, we can calculate that the entropy of Y will be log 2 of 3. So now we can write the capacity of this channel will be equal to log 2 3 minus H of alpha, where H of alpha is a entropy function. And if you plot this entropy function, we know its diagram will be like so. This is the diagram for H of alpha. And in our question, it is given that alpha belongs to range 0.25 to 1. So this value is 0.5 and half of it, here it is 0.25. So alpha can take values only in this range. Now it is asked in this question to calculate the value of alpha for which capacity is maximum. So for this term to be maximum, H of alpha has to be minimum. And in this diagram, you can observe H of alpha is minimum at this point. Its value is 0 and corresponding value of alpha is 1. So we can say that for alpha belonging to this range 0.25 to 1, capacity will be maximum when H of alpha is minimum. And you can observe here that for this range of alpha, H of alpha is minimum at this point and its value is 0. So minimum value is 0 and corresponding of value of alpha is 1. So this is the required answer that is asked in this question. Also you can calculate the capacity for this value. So it will be log 2 3. So next time the examiner may ask the maximum capacity of this channel also. So in the end, I will like to tell you one more thing, that this question was based on symmetric channel. And soon I will be making video on this type of channels. And in general, the capacity of such channel is log 2 size of y, that I am giving capital M, minus the entropy of any one row of transition matrix. So when I will be discussing these channels, I will be driving this capacity equation. So in the end, I will request to all to subscribe to my channel to watch these videos in future. And if you like this video solution, then please do press the like button below this video. So in the end, thank you all for watching this video solution.